This is Daniel back with another screencast. I'm going to go ahead and take a foray into explaining classes in .NET. So today I've got up my Visual Studio 2010 Professional, and I've already got a solution loaded here, so I'm just gonna hop into it, open up my Solution Explorer. And I've got a project name Exploring Classes. Taking a peek at the properties here, you'll see it's a .NET 4.0 project, outputting as a console application. Go ahead and close that. And go back to my Solution Explorer and open my class file. Okay, so here we see a pretty standard entry point into an application. I'm going to go ahead and break this down real fast just in case you're not 100% familiar. I've got a header, no using declarations, a namespace declaration that I'm apparently trying to drag around, the name for my namespace, and a class called program containing a static method called main, capital M, as an entry point. This can be changed, but it's the C# standard convention. I recommend you follow this format. If you need additional parameters, you can actually take in a string array here that accepts command line parameters. For the purposes of this demonstration, we don't really need that. So at this point, I've got a system console write line hello call that when I run it will just print out hello. So let's go ahead and set a breakpoint here so we don't overrun the end of execution. And we have hello. Congratulations. Okay, so at this point, let's go ahead and start making some classes. Now in Visual Studio 2010, it's really easy to do this using design first, but let's go ahead and do this the old-fashioned way. Let's go into the Solution Explorer, add new item, ignore all this. Let's go into a code class, and let's define the circle class. Okay, so here we have a class called Circle. Visual Studio automatically drops in a few using declarations and my default namespace for my project. And then the class name is taken straight from the file name, circle.cs, class circle. The first thing I'm going to do is I'm going to make this public. By default, if a class doesn't have a declaration before it, it's internal. Internal means it's visible to anything within the same project. Long version short. So at this point, I'm going to go ahead and start defining the members of my circle. Let's say an X and Y coordinate for the origin. Silly me. Bad notation. And then probably drop out my constructor here. Typing in CTOR and hitting tab twice will actually drop out the constructor by default, and we'll get into that in a second. Setting up initial values here. Should probably also have a radius now since this is a circle. It's not liking those. Oh, right, we have to define a type. It would help if it knew what kind of data we were talking about, wouldn't it? On second thought, alright then, so here we have the basic building blocks for a circle, but no way to access them. I just hit Control E, D to format the document in case you're wondering. That's Edit, Advanced, Format Document. Automatically fixes your tabbing and everything. So at this point we have a constructor. Now you'll notice that unlike most methods, which have a declaration that looks more like this, let's call this set x. Takes in a double and a field called x. Right? It has to have a return type, void. Okay, so set x returns nothing. Unlike a regular method call, a constructor has no return type, and it has the same name as the class. This has to match one-to-one. As a matter of fact, you'll see if I rename this using refactor to circles, they'll both change. So I'm going to undo that. And you can have multiple functions with the same name in .NET objects and C#. Sorry, not multiple. I said this wrong. Multiple functions or methods with the same name. I apologize. But as long as they have different parameters. So one way to do this, it's called overloading. One thing you can do is have a constructor that takes in all three parameters to create a new circle. So I'll show you what this looks like externally in just a moment, but let's go ahead and assume that the user is passing in parameters for X, Y, and Z. So let's set those. Did I say Z? I meant R. I apologize again. Okay, so at this point we should be able to pass in parameters via a constructor to set these private fields. And let's go ahead and give this functionality as well. While we're at it, let's define set Y and set R. At this point, we have a fairly well established, albeit somewhat esoteric, class that we can use to define a circle. So I'm going to go ahead and save that file and pop back out in exploring classes. Because circle has the namespace Firoso webcasts, it's visible in the same namespace as my exploring classes file, my exploring classes source file. So I should be able to go in here in main and just whip up a new circle. So IntelliSense automatically picks it up, and we can say new circle. Now normally you just do this, but we're creating a new class with parameters. That's where the constructor comes in. You see we've got 2 of 2 here. The 1 of 2 is the default constructor, and the 2 of 2 is the overloaded constructor that we created that takes in X, Y, and R coordinates. So let's say 4.0, 3.0, and 16.0. You can also denote this with F as a floating point number. Should like that because floats will upgrade to doubles, or you can go 16. That's an integer which will be promoted to a double as well. You can't do lossy type conversions the other way around. You cannot turn an integer, or you can't turn a double suddenly into an integer without losing data. But you can go the other way. So let's leave that at 16.0. Okay, at this point we will have created a circle right here, and we could use it. We could call methods on it like myCircle.setR, X, and Y. And you'll see there's a couple other methods here: equals, get hash code, get type, and toString. Now, what these are and where they come from, I'll get into in a later session. But if you're curious, check out system.object. So for now, let's change set R to, maybe I wanted it to be a 1.1, just cause. So I'm actually going to trace through the execution stack here by setting a breakpoint where we create the new circle. I'm going to hit run. We don't really care about our hello message. So at this point, if we take a look at locals, we've got my circle with a value of null. We're defining it here, but it doesn't have any initialized value. So that's what we're doing right here, is we're creating it. So I'm going to go ahead and step in, and we pre-construct our class with X, Y, and R equal to 0. And then we call the constructor, which passes in X, Y, and R, and sets local values. You can see X, Y, and R respectively just got set to 16, 4, and 3. So at this point we've already changed our values and instantiated our instance of circle, so let's go ahead and step back out. Now if we take a look into my circle, which is now instantiated, you can see R, X, and Y have values on our instance of my circle. This is an object, my circle, of type circle. Hope you can follow that. That's about it for now.